Hello learners, this is Education Online program. I'm teacher Lily. I'm going to teach chemistry, and our topic today is the quantities of substances in chemical reactions, and this topic is for senior 3 and 4. So what is these quantities of substance in a chemical reactions? This is simply showing how much or what is the amount of the reacting substances in a chemical reactions. How do we determine it, and how do we know that this is the amount of the reactants and this is the amount of the product? So this is what we are going to deal with in this lesson. So here the equation as it is written does not indicate only one possible set of amount, but it has to indicate some other different amounts of other substances. It means in a chemical reactions, and when you are representing the chemical equation, it doesn't show only one amount, for example like amount of moles of substance, but it is showing a lot of things there. So it means here we are not only dealing with the one set of things, but we are dealing with the many other amounts of substances. So in this case we are representing it either in the reactants or the products. As we have said that here we know that the products are on the left hand, the products are on the right hand side of a chemical equation, and the reactants are on the left hand side of the chemical equation. So they are going to show some quantities of substances present at the left hand side and also at the right hand side. So here different amounts of substances can react and be formed. So different amount of substances can react and be formed. It means here we are showing the moles, we are showing the masses of all the substances that are reacting to give the products, and also the product side will show the number of moles and the quantities or the masses that are being formed. So in this case we have to remember that, but with the relative amount, that is the proportion of the atoms that are reacting and the one that has been formed, they are always relative to each other. So in this case, they say it's always the same as shown in a balanced equation. So when you have a balanced equation, you have shown out that we have the number of atoms in the reactant side is equal to the number of the atoms in the product side. So that one is showing a balanced chemical equations. So here when we are talking of quantities of substances, we mean in a chemical reaction, the quantities of substances that are reacting should be shown clearly. Where in a chemical equations. So here we are saying that any chemical reaction is represented by a chemical equation, and a chemical equation shows clearly the quantities of the substances that are reacting. It means the proportion of the amount of the substance that are reacting together, that give the product. And also we have to know the amount of the substance or relative amount of substance that are being formed. So in this case we shall say that the moles at the product side is equal to the moles at the reactant side, or the reacting quantities of the reactants. Let me say you have different atoms at the reactant side, they will have the same number of moles or relative amount of moles. So in this case we say that the quantities of the substance of in chemical reactions should always be clearly specified. So the relative amount of any two substances involved in a chemical reaction is known as the mole ratio. Here the relative amount we represent it as the mole ratio. So in any chemical reactions, the substances that are reacting, or the relative amount of the substance that are reacting, we consider it as the mole ratios. So the relative amount the relative amount of substances, amount of any two substances, the relative amount of any two substances that are reacting, or that are involved, in a chemical reactions that are involved in a chemical reaction is known as the mole ratio. So whenever you are dealing with a chemical reaction, you have to put into your mind the mole ratio. So here the mole ratio is representing the relative amount of the substances that are reacting, and in this case we call it as the mole ratios. So here take the reaction between sodium metal and oxygen gas to give us sodium oxide. So for example, we are given a reaction between sodium metal and oxygen gas to give sodium oxide. So the various amount of sodium and oxygen can react to give various amount of sodium oxide. So in this case, have one, but the moles ratio between any of the two substances involved is constant. So in this case, we shall have that sodium, when it reacted with the oxygen, it gives us sodium oxide. But here we should say that the mole ratio of sodium and oxygen in the reactant side should all be the same as the one of the product side, which is sodium oxide. So we can put this one as an example. We shall have sodium metal and oxygen gas react to give sodium oxide. So in this case, we say that this is a reaction between metal, which is sodium, and a gas, which is oxygen. So the product form is sodium oxide. So here the product is sodium oxide, and the reactant substances is oxygen and sodium. So here we shall say that the various amount of the metal, which is sodium, and the gas, they will give us can react to give us the various amount of sodium oxide. So we have the various amount of these two substances will give us the amount here for the products. So it means here we shall have the amounts here are relatively equals to each other. So we shall have the product and the reactants, they have the same quantities of the moles. So in this case we shall say that here the mole ratio between any of the two substances involved will be constant. The mole ratio between the two substances involved, which is sodium metal and oxygen metals, will always be constant. So we shall have this represented as sodium. First of all, we need to balance this equation. We have sodium plus oxygen, and it will give us sodium oxide. So learners, is this equation or this chemical equation, is it balanced? We say no, it's not balanced. Why? Because we have sodium atom in the left hand side, the atoms on the left hand side of the atoms of sodium in the left hand side is not equal to the atoms of sodium in the right hand side. So in this case we are saying that sodium in the left hand side is not equal to sodium in the right hand side. So we have to go to see an oxygen. So oxygen here in the left hand side is, there are two atoms of oxygen, but when you come to the right hand side you will see that oxygen is only one atom. So in this case there are an equal balance of the atoms present in this chemical equation. So we need to balance it by adding some whole numbers or even numbers. So we shall say oxygen is 1 in this side, so it means we add 2. Here in this case we have 4 atoms of sodium and then 2 atoms of oxygen. So we shall say here we can add it to be 4. So what about oxygen? So here oxygen we have it 2 atoms, and here also we have it as 2 atoms. So both sides of the reaction is equal to each other. So we have 4 atoms of sodium in the left hand side and then 4 atoms of sodium in the right hand side. 2 atoms of sodium in the left hand side is the same as those ones at the right hand side. So the equation, we said it is a balanced equation. So we go back to our quantities or the chemical reactions that we are talking about. So we are going to say that these 4 here will represent the moles, and we say that there are 4 moles of sodium and 1 mole of oxygen. In this side we can say there are 2 moles of the product, which is sodium oxide. So we can put this one in words and say 4 moles plus 1 mole of oxygen. So we say 1 mole of oxygen, because here we are seeing that there is no number, but in this case we represent it as 1. So 1 in a chemical equation is not indicated or it is not written, but you have to know that when this place is empty, it means that we have 1 mole of that substance that is reacting. In this case we have 1 mole of oxygen gas. So when we go to the right hand side we shall see that there are 2 moles of the product. So 4 moles of sodium plus 1 mole of oxygen produces 2 moles of sodium oxide. We can also say that there is 2 moles of sodium metal. So 2 moles of sodium metal. In this case we know that this is a solid, and here we are representing it as a gas, which is Ng, and then here sodium oxide is also a solid. So the physical state of the reactants and the products we have already known them. We have said that sodium is a solid, oxygen is a gas, and sodium oxide is a solid. So we have 2 moles. Then sodium plus oxygen, we can represent it by having various amount. We can put it as 2 moles of sodium produces 0.5 moles. So when you divide 2 by 1, it will give us 1 over 2 will give us 0.5 moles. So it means here we have 0.5 mole of oxygen gas. So what will be the ratio here is 1 mole. So if you take the amount of the first reacting substance, which is the metal, and you change it into 2, then you divide this by the amount of the mole that you put in the first place. So here we divide 1 over 2 will give us 0.5. So again, when you divide 2 over 2 will give us 1 mole. Again, if you change the mole of sodium, here we are saying that there are various amount of substances that are reacting. As I said before, that there are various amount of substances that are reacting in a chemical reaction. It means you can alter the number of the moles, and then you divide the rest of the moles of the other atoms together in both sides of the chemical reactions. So we shall have 2 moles, and we have 5 moles. 5 moles, and when you divide 5, 1 over 5 will give us 1.25 moles, which is representing the one of oxygen molecules. So when we go to the product side, when you divide 5 by 2 will give us 2.5 moles. So here we are representing the moles in a various amounts. So again, when you change the amount here, we shall have, if you say 0.1 mole of the metal, which is sodium, will give us 0.025 mole of oxygen. Again, this will be 0.05 moles of the product, which is sodium oxide. So that is why in this we are representing the quantities of the substance with a various amount. So in this case, when you change the amount of the first substance reacting, we shall have various or different amount of the substances. So we shall have different amount of the substances being represented. As you have seen in this reaction, we have various amount, which are like 4 amounts of the moles, and each of them is giving us different amount of the moles that are reacting. So in this case, we shall say the mole ratio will be equals to, and here is representing the value of the moles. Then we have sodium divided by oxygen. So here oxygen is the atom that reacted with the sodium atom. This will be equals to, the first row here is showing us that there are 4 moles of sodium and 1 mole of oxygen. So we put 4 moles above and then 1 mole below. This is the same as, also we have 2 moles of sodium and 0.5 moles of oxygen. So this is also the same as 5 moles over 1.25, which is also the same as 0.1 over 0.025. So it is evident that not only 4 moles of sodium which can react with 1 mole of oxygen to produce the moles of sodium oxide. So we have seen that the various amount can give us the moles of sodium oxide produced in the product. So we shall have that this is representing the various quantities of the substance that are reacting in these reactions. We can have a step in calculating the quantities. So we can have a step for the calculation of the quantities. We have now to know that these quantities, they have a step for us to guide us at least to know how to calculate the quantities here. So we shall have a step in calculating quantities. So here we have seen that the first thing is to write the balance equation. Write the balance equation. Number 2, as you have seen here, we have started by balancing the chemical equation. So number 2 is to find the number of moles. Find the mole ratios. In this matter, we are saying we got the mole ratio of sodium to the mole ratio of oxygen. So in the first one we have 4 to 1, 2 to 0.5, and we continue. So find the mole ratio of all the substances involved. So number 3, equate the mole ratio and calculate the required quantities. So after we divide this 4 over 1, then we get we calculate it out and we get the required quantity. So we have to equate the mole ratios and calculate the required quantities. So with this, we know that we have gone through all these 3 steps. So those steps are very important when you are dealing with the quantities of the chemical reaction, the reacting substances in a chemical reaction. What are their quantities? We need to follow the following guide. So here we shall have an example to verify how we get these quantities. For example, you will be given a chemical reaction and then you calculate the number of moles, and it is usually represented at the standard temperature and pressures. So you have 6.54 grams of zinc metal reacted completely with dilute hydrochloric acid. Reacted with dilute hydrochloric acid, and this reaction reached to completion. So acid at standard temperature and pressure. So you are required to calculate 1, the number of moles, the number of moles of hydrochloric acid. Hydrochloric acid that reacted. So you are required to get first the number of moles of hydrochloric acid that reacted. 2, you are asked to get the volume of hydrogen gas. The volume of hydrogen gas produced. So in this case, you are asked to do the following things. First of all, you are asked to get the number of moles of hydrochloric acid that reacted and the volume of hydrogen gas that is produced. It means in this reaction, we shall have the equation to be the equation or the chemical equation is zinc plus hydrochloric acid will give us zinc chloride plus hydrogen gas. So these are aqueous solution. Gas is represented by G, and we have hydrochloric acid as aqueous, and then zinc is a solid. So all of them are having their physical state indicated, and we have a balanced equation by adding 2 in front of the aqueous solution of hydrochloric acid. So here the mole ratio, the number of moles of zinc, reacting will be equals to the grams, which is given 6.54, which is the mass, 6.54. Then we divide by the molar mass of zinc. The molar mass of zinc, if you go back to the periodic table, is 65.4. So here we shall have the moles to be equals to 0.1 moles of zinc. So the mole of zinc here is 0.1 mole. So here the mole ratio of zinc to hydrochloric acid, according to the equation here, is 1 to 2. So we shall have 1 to 2. It means we are going to multiply the number of moles of zinc with the 2. So we shall, with the 0.1 multiplied by 2, which is for hydrochloric acid, so that we get the number of moles of hydrochloric acid. So we shall have number of moles of hydrochloric acid will be equals to 2 multiplied by 0.1, which in this case is 0.2 moles. So to get the volume of hydrogen gas, we shall have the last part, which is the standard temperature and pressure, and we multiply by the mole ratio of zinc to hydrogen gas. So here zinc is 1 and hydrogen gas is 1. So we shall say that in the second request, shall say the moles ratio of zinc to hydrogen gas will be 1 to 1. So in this case, the number of moles are going to be the same. So we shall have 0.1. The moles of hydrogen will be equals to 0.1 moles. So you are required to find the volume of hydrogen gas. So we are going to multiply the volume of hydrogen gas will be equals to 0.1 multiplied by 22.4. So here 22.4 decimeter cube is the standard temperature and pressure. So we shall say this will be equals to 2.24 decimeter cube. So this is representing the volume of hydrogen gas produced. So with these learners, we have learned how to get the quantities and the mole ratio of the substances that are reacting. So in this case, we have known the volume of the substances that are of hydrogen gas that has been produced. And with this, we have come to the end of this lesson. So thank you very much.